Okay, let's do another example of using Jacobians to transform a double integral. Okay, I'll call this example 3. Evaluate the following. I equals the double integral over r of 6x minus 3y dA, where r is the parallelogram with the vertices 2, 0, 5, 3, 6, 7, and 3, 4. They suggest we use the following transformation. X equals 1/3 v minus u, y equals 1/3 4v minus u. Okay, now what I've done here is went ahead and graphed the parallelogram here, and it does indeed look like a parallelogram here. I found the equation relating x and y for each of the four sides of the parallelogram here. So this is some aside work here that would be some basic algebra that you can do on your own here as you go through the problem, but I've already done for you here. Okay, so let's go ahead, and you can see here one side is y equals x plus 1, another side is y equals x minus 2, and then you've got two opposite sides here, y equals 4x minus 8 and y equals 4x minus 17. So my first order of business is to translate these into terms of u and v here. Okay, so if we've got y equals x plus 1, this becomes 1/3 4v minus u equals 1/3 v minus u plus 1, multiplying through by 3. 4v minus u equals v minus u plus 3. Solving for, let's see, we could knock the u's out. We would get 3v equals 3, so that means this is actually the set of all points uv in the uv plane such that v equals 1. Okay, so that would be a horizontal line in the uv plane if we use u as the horizontal and v as the vertical. Y equals x minus 2, this would be 1/3 4v minus u equals 1/3 v minus u minus 2. This ultimately would break down multiplying on 3 on each side, minus 6, which becomes what? 3v equals negative 6, v equals negative 2. Okay, so there we've got a couple horizontal lines for the boundaries of the region we're going to call r star in the uv plane, which is the pre-image under the transformation t, yielding the parallelogram r. Okay, let's look at the other side. So we've got a couple sides here already in terms of u and v. Let's look at these. Let's go with y equals 4x minus 8. So that would mean that 1/3 4v minus u equals 4 times 1/3 v minus u minus 8. Okay, and that would mean 4v minus u equals 4 times the quantity v minus u minus 24. And that looks like, do a quick mental arithmetic here, I think that would be 3u equals minus 24, so that u is negative 8. Okay, so that would be a vertical line in our uv system here. 4x minus 17. Okay. Let's see, so this ended up being minus 8 because of this, then taking a third. So I think this would be u equals minus 17. Okay. check me on that there. What's a r star? That's the preimage, so t of r star should be our parallelogram r, right? So what would this be in the uv plane? Okay, so here's the u-axis, here's the v-axis. Okay, let's see, we've got u equals negative 17. Okay, let's not call that the v-axis. This is cheating. U equals negative 8. Okay. U equals negative 2. And say U equals 1. Notice what they've been doing is setting up these transformations so the original R ends up being a nice rectangle in the R star ends up being a nice rectangle in the UV plane there. So this is what we're integrating over here. So this looks not too bad here. Okay. What do we have to do next? We have to find the Jacobian. Okay, let's go ahead and do that here. Okay. Remember, we're sticking with partial derivatives of x with respect to u and v for the first row. So that would end up being, come back here, remember we have this, okay? What's the partial derivative of x with respect to u? That would be minus 1/3, wouldn't it? How about with respect to x with respect to v? That would be what, 1/3, I think. Okay, can you see that? Okay. Now we need to do that partial derivative of y with respect to u. Y with respect to u ends up being what? Minus 1/3. And then with respect to v becomes 4/3, doesn't it? So we can see this is just going to end up being a constant here. So that ends up being negative 4/9, right? When we multiply here, minus negative 1/9. So that's negative 1/3, because that becomes negative 3/3. The absolute value, which is what we're really looking for, ends up being the absolute value of minus 1/3 is 1/3. Okay, to evaluate the integral, remember the integral looks like this, the double integral over r of 6x minus 3y dA. Okay, so that's going to be the double integral over r star. Don't forget we have to change what the integrand also. So that's 6 times v minus u over 3, right? X minus 3 times 4v minus u over 3. And don't forget we need to have this guy in there, right? 1/3. I'll go du dv. It's not going to matter, right? Remember, r star is a rectangle. Okay, so the order is not going to make. It's just going to be as easy one direction as the other. So let's go ahead and do that. Let's see. U was going from what? Minus 17 to minus 8. And v was going from minus 2 to 1. Okay. Okay. Back in my picture, I messed up here. These should have been v's, right? You probably noticed that. Okay. Okay. All right. Well, anyway, let's keep going here. What would our integrand be? This would be what? 2v minus 2u. This is all over 3 from the 1/3 here, minus 4v minus u du dv. Okay. All right. So there's our integral here. So that's I. Okay. All right. What do we get for that final answer here? Okay. Minus 2 to 1 minus 17 to minus 8. I think we get negative 2v plus u all over 3 du dv. Okay. I guess there should be a minus sign, shouldn't it? There should be a minus sign also. Looks like I messed up there, but I caught it. Okay. Yeah. This is what I'm getting. Negative 2u plus another u makes negative u. Okay, so I guess we have a negative sign out of everything. Maybe I'll just do this, negative 1/3 at the end, from minus 2 to 1, negative 17 to negative 8, 2v plus u du dv. Okay, let's do this integral from negative 17 to negative 8. 2v plus u du would be what? 2uv plus 1/2 v u squared. U is going from minus 17 to minus 8. So that would be negative 16v, 64 halves, right? So that would be 32, I think, when we evaluate that. Okay. Negative 17, so that would be negative 34v. Okay. What's 17 squared? Isn't that 289? 289 over 2? Yeah, that's not so pretty. Okay. Well, let's see. 34 minus 16 would be 18. Okay. And let's go ahead. This is a subtraction sign here, isn't it? So we've actually got minus 64 from there. Isn't that 225? Or 227, sorry. Writing like a student here. 64. No, I was right the first time. 225, 15 squared. Okay. That's what? 18v minus 225 over 2. Okay. All right. Then we got to integrate that with respect to v. So I is going to be negative 1/3, integral from negative 2 to 1, 18v minus 225 over 2 dv, which is equal to negative 1/3, 9v squared minus 225v over 2, going from minus 2 to 1. So that's negative 1/3. Evaluate at 1, we get 9 minus 225 over 2. Evaluate at negative 2, 36 plus 225. Okay. Negative 1/3. That would be what? 18 minus 225 all over 2 minus 261. Okay. Okay, I guess. Okay, negative 1/3. What is this? apply the negative sign through. I'll go plus here. I get 225 minus 18 all over 2 plus 261. Okay, so that's what, 207 plus 522 all over 6, right? So that's 7, right? 729 all over 6. Okay, it looks like we can take 3's out of there, right? Isn't that 3 times 24? Taking 3's out. And I guess that's, I guess we can just leave it like that. Okay, so there's our final answer. Modulo any arithmetic errors I made along the way.